with us. Now, may I request Dr. Bishwanath Banerjee, sir, to kindly take over the session. Thank you, and over to you, sir.
Thank you very much. I will first of all open my presentation window. A very warm welcome. Am I audible?
Yes, sir, you are audible.
Okay. Very warm welcome to all the participants in the ATAL Academy online FTP on management of hydrocarbon exploration and production waste, organized by the Petroleum Technology Department of Dhrubajyoti University. First of all, I would extend my thanks to HOD Madam Subrata Borgohai Gogoi and the coordinator Dr. Dhrubajyoti Neog for inviting me and giving me an opportunity to share some of my knowledge on this topic. Today, my topic is environmental impact of oil well drilling and production operations and disposal of waste. In fact, I have divided the topic into two parts. Part one will be on environmental impact of oil well drilling operation and disposal of drilling waste. And part two will be on environmental impact of oil production operation and disposal of production waste. So now we start with part one, environmental impact of oil well drilling operation and disposal of drilling wastes. The content of my talk would include a very short introduction to drilling to understand the environmental angle. Second, we will in detail analyze the environmental issues of oil well drilling operation. Third, we will in detail discuss the management of waste which is generated in oil well drilling operation. And finally, we will uh, ponder on some of the important points to go way forward. We drill oil wells on land part. These wells are called as onshore wells. We also drill wells in ocean on the seabed. These wells are called as offshore wells. You can see here it is onshore well drilled on the land part, and it is offshore well drilled on the seabed in the ocean.
Sorry to interrupt, sir. Slides are not moving.
Oh, not moving. Arre.
Yes, sir.
This was happening last time also in the FIPI
Okay.
presentation. I don't know what is happening.
Sir, can you make it full screen, sir?
It is already full screen.
Sir, you do one thing. You
Ah,
click on slideshow.
acha. Now can you
Slideshow.
see? Can you see now?
Full screen is not coming, sir.
Acha.
Can you just click on slideshow on upper?
I have done that. I can see the full screen on my laptop.
Okay, sir.
So what can I do?
No, sir. No. Don't minimize, sir. Come to the left side, sir. Left side.
Left side.
Upper left side, sir.
Upper left means?
Near animation, slideshow is there.
Yeah. Slideshow is here.
You just click on that.
I have clicked on this.
What
You
is
can't see it. Yeah, I can see it on the full
okay?
screen. Yeah.
Okay, then you select the second option.
Second option means.
When you click on the slideshow,
Mm-hmm.
there will be a different option to select. Select what is written in the second option, sir.
Second
Not this one,
option.
sir. Not this one, sir.
Then
On top of the
slide
bar, sir.
top of the
Just
bar. Acha. Acha, acha.
yellow, blue part, sir. Blue part, sir.
Acha, acha, acha. Okay, okay.
Okay. Click
Slideshow.
on that,
This.
sir. Then
Yeah, yeah.
set up slideshow, sir.
Setup
Click on setup
slideshow.
slideshow. Yes, sir.
Yes, yes, yes. Yes, I have done
Then,
it.
sir, click on the second option, sir. Second option.
ये browsed my
This one,
individual.
this one, this one, sir. Yes, correct, sir.
Huh? This
This one
one?
you click. Yes, sir. Yes.
Okay.
Click on that, sir. Then you
Click
make it manual, sir. Manual.
manual.
Here, sir. Right side, sir. Advanced slides.
Okay, okay, manually. Okay,
Manual.
okay,
Then,
okay.
sir, you click on OK.
Click on OK. Acha.
Now
Now,
make it a full screen, sir.
acha.
Yes, sir. It is coming, sir.
Okay, okay, okay. Right, right. It is moving also.
Yes, sir. Yes, sir.
Okay, okay. Right. Okay. So the content of my talk would include a very short introduction to drilling operation pertaining to environmental angle. Second, in detail, we will investigate the environmental issues of oil well drilling. Third, we will discuss the management of waste generated in drilling operation. And ultimately, we will think on some points for way forward. We drill oil wells on the land part. These wells are called as onshore well. We also drill oil wells in the ocean on the seabed. These are called offshore wells. The equipment which is used for drilling oil well is called a drilling rig. Basically, the onshore rig and the offshore rig are same, but in the offshore we have to do some modifications depending on the water depth of the ocean. Now we come to drilling fluid circulatory system. Drilling fluid is the heart of drilling operation. You can see in the upper diagram, the drilling fluid removes the rock cuttings from the well bottom to enable further drilling by drill bit. And this mud is pushed inside the wellbore through the drill pipe, which comes out with a force from the nozzle of the drill bit. The mud takes or carries the cuttings up to the annulus. Annulus is a space between the wellbore wall and the drill pipe. The mud along with the cuttings come out at the surface. Here, the mud is cleaned and then again pushed or pumped inside the drill pipe. It is drilling fluid circulatory system. It has a large bearing on the environmental angle. We will discuss this later. The drilling fluid or the mud is basically of three types: water-based mud, in which the base fluid is water; oil-based mud, in which the base fluid is diesel or oil; synthetic base mud, in which the base fluid is a synthetic liquid similar to oil. Now, The mud is basically a suspension or a colloidal system of water and clays, for example, bentonite. But some drilling fluid additives are added to it to achieve the desired functions or properties of the mud that are essentially required to drill a well in a smooth manner to reach up to the target in a given time. Drilling fluid additives are of many types. I am giving here just the names of those types and some of the examples just to show you the wide range of drilling fluid additives which are added in the mud and which have a huge bearing on the environment. So these additives are pH controllers, bactericides, calcium removers, corrosion inhibitor, emulsifiers, fluid loss reducers, flocculants, weighting agents, lubricants, pipe stuck-up ear release agents, shale swelling inhibitors, thinners, polymers, and lost circulation materials. These are chemicals, organic, inorganic, and some other substances as well. We will see later on how these are creating environmental problems. Now we come to the second section, environmental impact of oil well drilling. Environmental impact of drilling operation can be understood or evaluated under 10 categories. Number one, water acquisition issue. Two, liquid waste generation, solid waste generation, soil pollution in case of onshore well, seabed pollution in case of offshore well, surface and groundwater pollution in case of onshore well, and ocean water pollution in case of offshore well. Then air pollution, noise pollution, night light pollution, loss of vegetation, and disturbance to your wildlife in case of onshore well and marine in case of offshore well. Now we will discuss one by one. We will see what are these, what are the sources of these environmental problems, and how we can deal with them. Point number 2 and 3, their dealing or coping up will be discussed under the next section of management of waste, because these two are the waste generated in the drilling operation. Now we go to first, water acquisition. Water acquisition means withdrawal or taking out of the groundwater or the surface water for various activities like making drilling fluid, washing the rig, washing cuttings, mixing the chemicals, for site accommodation, and for uh, laboratory work. Although in drilling operation, water requirement is not much, so it will not be a big issue. However, there can be certain areas where the impact of water acquisition could be significant. These areas are, for example, areas with high well density, where many wells are drilled in a small area. Areas where there is less water availability. Areas which are arid or dry. Areas with high human density and high agricultural area, and industry area. So in these areas, there will be a tussle between the water use between the oil industry drilling operation or human consumption for agriculture, etc. How to deal with water acquisition issue? We must optimize the water requirement, and we should minimize or eliminate the wastage of water. It is, you can see a lot of water is being wasted there because of careless handling. And then we should treat the water and again reuse it for washing purposes, etc. Second is liquid waste generation. These are like spent drilling fluid, whole WBM or OBM, mud with additives, waste lubricants like lube oil and grease, wash water. It may contain mud, chemicals, lubricants, and well site drainage, which comprise kitchen drain, the drain from the accommodation, living accommodation, and the laboratory. So these are the contributor to liquid waste generation. Now you can see here, this is a percentage of chemical composition in the water-based mud discharge. You can see there are several chemicals, weighting agent, uh, salinity, and other additives are there in the mud discharge. Similarly, in the oil-based mud also. Now we come to solid waste generation. Solid waste is generated mostly in the mud cleaning system at the surface when the mud returns back from the wellbore. It passes through shale shaker, desander, desilter, mud cleaner, centrifuge, settling pit, and in due course, it gets cleaned. And now the cleaned mud is again pumped into the wellbore. Apart from this, some bulk chemicals like bentonite, barite, viscosifier, cement, etc., also contribute to solid waste. And the sanitary waste from the site accommodation is also a small contributor. Now you can see that the drill cuttings is estimated in the range of 130 to 560 cubic meter per well. So it is a pretty huge amount and must be managed. Solid waste is generated at the surface, I told you. This is shale shaker. It is a simple vibrating screen of 10 to 150 mesh, which is capable of separating the coarse particle, mainly the well cuttings from the mud. It is photograph of a double screen shale shaker. Descender. It is basically a series of hydroclone with a diameter more than 6 inches, and it separates the solids of 40 to 45 micron range particles based on the centrifugal force principle. Desilter is also same as the descender, only difference is the small size of the hydroclone. It is less than 6-inch cone. It removes 10 to 20 micron range solid particles. Mud cleaner is basically a desilter unit in which the out mud is passed through a thin vibrating screen. Here you can see, and it separates the fine particles of inert additives like barite, iron oxides, etc. And these are again sent back to the mud system for flow. Mud centrifuge is basically a rotor drum. The mud is pushed into the drum, it is rotating, and the solid particles are pushed to the internal wall of the drum, and then they are coming out or excreted. This is settling pit. It is a pit which has been dug in the earth to receive the mud return. It allows the solids to settle at the bottom. Now we come to the soil and seabed contamination and surface and groundwater contamination and ocean water contamination. Both have the same sources of contamination. So we are studying it together. There are various contamination sources like spillage of drilling fluid, leakage of the drilling fluid or mud from the channel, from the pump, from the equipment, from the pipeline, washings during drilling, spillage of chemicals by careless handling, and we know that more than 3,000 chemicals are used in drilling operation, and about 50% of these are discharged as waste, and therefore it is a big environmental problem. It will contaminate the soil, the seabed, the groundwater, surface water, everything. These pollutants have been categorized into list 1 and list 2 pollutants. List 1 pollutants are those substances or chemicals which are toxic, persistent means they cannot be destroyed, and possess the bioaccumulation properties means they get accumulated in the body of animals and plants. Some of the examples are here. These are organohalogen compound, organophosphorus compounds, mineral oils, mercury, cadmium, and petroleum hydrocarbons, etc. List 2 pollutants are those chemicals which have adverse effect on the aquatic and marine life. These include mainly the heavy metals and their compounds. We know heavy metals are zinc, chromium, lead, barium, cobalt, arsenic, etc. Also, some other organic and inorganic compounds like biocides, phosphorus, cyanides, fluorides, ammonia, mineral oil, they also come under list 2 pollutants. Now, how to deal with soil pollution and water pollution? We must deliberately avoid spillage of mud. We must deliberately avoid the leakage of mud from the machines and the circulatory system. If there is any leakage, we should plug it, repair it, maintain well our equipments. We should collect the washings and treat them properly and again reuse them. We should avoid spillage of the chemicals in the storage area and during mixing in the mud. And we can use the environment friendly and non hazardous chemicals as as additives to drilling fluid. Now we come to six, air pollution. Sources of air pollution include mainly the exhaust coming out of the transport vehicle, heavy vehicles, engines, turbines, compressors, etc., pumps, and the gases evaporating from the mud channel, open mud pits, and chemical storage areas. These pollutants are particulate matter, for example, dust by vehicle movements, diesel PM 2.5, PM 10. It also includes VOCs, volatile organic compounds like BTEX, polyaromatic hydrocarbons, phenols, formaldehyde, glycol, and also gases like H2S, CO2, CO, methane, hydrocarbon vapors, etc. So these are the agents of air pollution. Methane and CO2 are of special interest and importance because they are causing the global effects. Since these are the greenhouse gases, they are responsible for global warming and climate change. There is a big hue and cry these days about climate change, and a global effort is being pushed for containing the global warming, and methane is 21 times more potent as a greenhouse gas than CO2. So we must somehow contain the methane and CO2 emissions during our operations. Although it is unavoidable, but it can be minimized. Number one, by reducing the carbon emission. We can use the energy efficient machines. We can use gas as a fuel rather than diesel as a fuel. We can restrict the use of air polluting chemicals, and we can use technologies to reduce the emission of dangerous hazardous gases. Seven is noise pollution. Noise is generated mainly from the movement of transport vehicles, road construction time, well pad construction period, movement of the rig, installation of the rig, and in fact, the entire drilling process is highly noisy. Noise pollution is also unavoidable, but maybe minimized by using some best practices. Night light pollution. This is a photograph of a drill site in the night time. You can see the entire area has been highly illuminated, and so that the entire sky is illuminated and appears as if it is morning. So it disturbs and confuses especially the birds about the timing and the direction. This can be minimized by restricting the light to focus downward to avoid the spreading on the entire sky. Ninth is loss of vegetation. You can see here that whether we are drilling in a forest area or a agricultural area, we have to cut down trees and destroy some of the crops to develop a drill site. So it is a big issue, and we have to take environmental clearance from the government which is often not so easy. This can be minimized by using slim hole technology of ear drilling, and we must do heavy plantation in that area after the drilling has been complete to somehow compensate that loss. At the last, we come to disturbance to wildlife and the marine life. It is because of the human movement, vehicular movement in the onshore, ships and vessels moving here and there in the offshore, helicopter flying in the offshore, noise pollution, vibrations, night light pollutions, vegetation loss, disturbance to marine organisms in offshore, disturbance to marine birds, and changes which are occurring in the soil, sediment, water, and air quality, both in onshore and offshore areas, and biodiversity degradation and ecosystem imbalance. All it is happening on the on-land and offshore both. And since the industry has entered in a big way and will be doing maximum exploration, drilling, and production in the deep water and ultra deep water, the marine pollution and the environmental impact offshore will become a very big issue. This is a schematic diagram of a offshore drilling platform. You can see here exhaust going to air, flaring CO2 methane into air, vents into air, light pollution. It is a supply ship, exhaust from here, sounds, vibrations, oil spills, and we are throwing the food waste, sewage water, drains, produced water, cuttings, everything in the ocean water. Accident. This is not a routine activity of oil well drilling operation, but accidents can happen, they do happen. And you can see here in onshore, the blowout followed by fire. In an onshore rig, you can see here the rig has toppled here down and the well is blowing. It is offshore. You can see the platform is burning, but it is an accident. It is not a routine environmental issue. Now we come to management of waste generated in oil well drilling operations. We have seen the various environmental issues in terms of pollutions and waste generation. The waste were two, liquid and solid. Now in this section, it is devoted to how to manage this waste. We will be managing liquid waste and the solid waste. There can be two approaches for this. A, waste management approach, and B is waste disposal approach. Waste management approach aims at reducing the quantity of drilling waste. And there could be several ways of doing this, like slim hole drilling, horizontal and multilateral drilling, use of synthetic base oil mud, road spreading, use cuttings for concrete and bricks, and restoration of the wetlands with cleaned cuttings. We will discuss these one by one. Uh, B is the waste disposal approach. It includes approaches like burial, waste pits, landfills, bioremediation, thermal treatment of waste, underground injection, and treated mud and cuttings directly disposed in the ocean. Now we come to slim hole drilling. You can see this is a conventional well. The left one is a conventional well and it is the slim hole well. Slim hole means the diameter is uh, very much less than the conventional well. It would mean a small drilling rig will be used, casings and tubings will be of small sizes, and the area of the drill site will be very small in compared to conventional site. And the most important is that the around 40 to 70% of mud volume and cuttings volume will also decrease, and in this way less waste generation. So we have generated less waste, we are reducing the waste generation. Second is horizontal and multilateral wells, etc. You can see in this diagram, this is a vertical well which covers a very small portion of the oil reservoir. It means we have to drill several vertical wells close by to extract oil from that reservoir. However, in case of a horizontal well, you can see one well covers a large portion of the oil reservoir. Therefore, very few wells will be drilled in that area. It means less waste generation. Use of synthetic base mud. There are basically four types of base fluids which are used to prepare SBMs. These are synthetic hydrocarbons, ethers, esters, and acetals. We will see what are these. Synthetic hydrocarbons mainly include linear alpha olefin LAO. These are the straight chain olefin with terminal double bond. Poly alpha olefin is polymer of the same. Internal olefin is a straight chain olefin with double bond somewhere in the middle of the chain. And linear alkyl benzene is a phenyl substituted normal alkane straight chain, long chain. These are mostly C14 to C1820 length chains. Ethers, you know, esters, you also know, and acetals. Now, synthetic base fluids are very, good because they are biodegradable and therefore they are environment friendly. Also known as low toxicity oil based mud. They have the properties of oil based mud but are easily biodegradable and therefore environment friendly. If you see the order of ease of biodegradation process of these, you will find that esters are most easily biodegradable. Then LAO, then IO, then PAO, and ultimately oil. So they are the best muds base for drilling. Fourth is road spreading. What we do, we mix asphalt in the construction material and spread it on the roads during road construction. But asphalt has many heavy, metals which are very harmful. But if you mix drilling waste, cuttings, and mud into the construction material and spread on the road, it will eliminate the harmful effect of asphalt being used, and the oily part of the drilling waste will act as a binding material. 5 is reuse of the cuttings as uh, construction materials, like we can mix it in the concrete, make the bricks, blocks for building erection. 6 is restoration of wetlands and clean cutting with clean cutting. You can see here we have spread the cuttings all over the water area, and after some time we have reclaimed that area, and now it can be used for growing of plants. This was about the waste management approach. Now we come to waste disposal approach. Burial is means the placement of the waste in either a man-made or a naturally available pit or on the landfills. It is the most common, most easy, a method. And drilling waste from the offshore is also brought and are buried in this way. They are low cost, low technology, but the waste may contain contamination, which may have leaching problems and may contaminate underground water and soil. Waste pits are dug and the waste are put in that, and we use a polythene liner to avoid the percolation of the hazardous chemicals inside the earth. Third is landfill. Cuttings are placed in a containment area, designated area, with a liner and a cover, because it is a long-term storage, so it has to be carefully covered and lined. Bioremediation is the degradation of waste by uh, bio agents. Now, there are land farming. What we do, we spread the waste on the land and mix it into the soil. The soil already has some active aerobic microbial population which destroys the waste constituents. Second is composting. In this, drilling waste is mixed with soil, wood chips, straw that provides increased porosity. Why? To ensure better aeration potential, so that uh, the bacteria can survive in a better way and do their work. Sometimes nitrogen and other nutrients are also added in the soil to enhance the microbial activity. You can see the composting mixture is placed in piles, and they are always tilted to ensure better aeration. Vermiculture is a process of using worms to decompose the organic waste into manure. Now, fifth is thermal method. In this, number one is called incineration. Incineration means burning of the waste and its complete thermal decomposition. Advantage is volume reduction and complete destruction. But the fly ash may contain heavy metals which may present a leaching hazard when it is placed in a landfill area. Second is thermal desorption, not burning. Here, A is indirect rotary kilns method. It is a rotary kiln which rotate. The waste is pushed inside. The kiln is heated from the outside by burner or thermal oil or by electricity. So it is indirect heating, and the contaminants from the waste They are heated and they go off as volatile matter. B. Thermal phase separation. In this, we do indirect heating, but we target some particular range of contaminants. So we increase the temperature to the boiling point of those target compounds. They get vaporized, vapors are collected, cooled, and contaminants are recovered. They can be used or can be uh, disposed of. C is thermal plasma volatilization. This is a unit. Basically, the waste is plasma pyrolyzed with the help of a plasma torch. Plasma pyrolysis is a process of thermal decomposition of organic matter part of the waste in the absence of oxygen. So it will not burn, it will only degrade. It will crack into smaller and smaller molecules, and ultimately we will get CO and H2 as gas, and it will go out. Now, six is deep water injection. What we are doing here, the drill cuttings and other wastes are mixed and made into a slurry. This slurry is injected or pumped inside or pushed inside into a dedicated waste disposal well. And the waste is basically pushed into a porous and permeable rock which can accept and accommodate that waste slurry easily. And this will be below the freshwater aquifer to ensure that there will not be any contamination subsurface. 7 is disposal in offshore. We know that in the initial offshore drilling process, the mud cutting, the cuttings are uh, discharged at the seabed. This is happening when the riser has not been installed. But after the riser has been installed, the cuttings are coming up, the mud and the cuttings are cleaned and they are discharged as waste in the ocean. And you have also, okay, right? So ultimately, the treated waste is thrown in the offshore waters. So this was about how to manage the solid and the liquid waste generated during the oil well drilling operation. Now we come to way forward. We will see that there is an issue of environmental, there is always a hue and cry, accidents do happen, and every time media and the governments, they makes the, I mean, the rules stringent, but still then drilling is going on and it will be going on. Then what to do? We have to, industry has to consider that we cannot pollute the environment, we cannot contribute to a global warming and climate change. So something has to be done. What is that? It is very clear that although alternate energy sources like solar, wind, hydrogen, ammonia, etc., they are coming to replace oil and gas. But it is a far cry still, until and unless some alternate energy source becomes cost effective and available in plenty, the oil and gas will continue, and also coal will continue to dominate the energy mix for several years to come, undoubtedly. we will make hue and cry about climate change, global warming. Meetings will happen at the international levels. The commitments will be made to decrease the emissions. Mm. We will do efforts also, but still, till we generate some effective alternate energy source, the oil and gas will be continuing as energy source. And therefore, the environmental impact of drilling will continue to be a challenge. And governments will continue to impose more strict environmental uh, regulations in respect of health hazard and climate change, etc. But drilling oil well cannot be stopped. Now, what the industry imperative is then? Industry must find and implement newer methods, approaches, ways, and technology to minimize or eliminate the adverse effects of oil well drilling. And these are especially, we must be able to reduce air, soil, water pollution, especially carbon emission, which can be done through best practices and application of new technology. We must, develop environment friendly, high performance, cost effective, water based and oil based drilling fluid formulations. Also, improved, cost effective, synthetic based formulations. We must you develop high performance, cost effective, environment friendly drilling fluids, especially for deep waters and ultra deep water, low temperature applications, because industry's future is in deep water and ultra deep water. And there are several challenges and problems, and the main one is the environmental issue. So we must find out some solutions of eco-friendly and effective, cost-effective, high-performance drilling fluids for deep waters. Some nanotechnology applications are being worked out. Environment friendly and biodegradable drilling fluid additives must be researched on, and effective drilling waste treatment technologies can come up, and safer waste disposal methods. So we have seen in this lecture that uh, the drilling oil and gas well is an essential part of oil industry, and it is essential for the energy, meeting the energy demand of the world. And there are environmental issues undoubtedly, and some of these are being met, but we are also ignoring many, and we should try to do everything, best practices, technology acquisition for better management of waste handling, etc. Thank you very much for patient listening. Uh, Now we will shift to part two. Give me some 2 minutes time. he told me slideshow, setup slideshow, browse by individual, manual, okay. Now, can you see the slide
Yes, sir, it is coming, sir.
coming? Okay. It
Yes, sir,
is
yes.
is it changing also?
Uh, yes, changing, sir. Changing.
Changing? Right.
Yes, sir, yes.
So now we come to the part two of the lecture, which will be dealing with the environmental impact of oil production operation and disposal of production waste. The content would comprise a very small part on the definition of conventional and unconventional reservoirs in relation with environmental issues, on-land surface production system, offshore surface and subsea production system, hydrofracturing for unconventional reservoirs. Then in detail, we will see the environmental issues in on-land and offshore production systems, including hydrofracturing. And the waste here is mainly produced water. So we will see its treatment and subsequent disposal and ultimately way forward. Now, conventional and unconventional reservoirs. Conventional reservoir is that reservoir in which the rock permeability is greater than 0.1 millidarcy. It is obvious that the permeability is good and therefore the oil and gas can move out from the reservoir very easily, smoothly during production. And it requires conventional technology, normal methods to produce oil and gas. For example, we can say conventional oil and gas reservoirs occurring in sandstones. Unconventional reservoirs are those in which the rock permeability is less than 0.1 md and it goes up to 0.0001 md. It means the permeability is very bad, the rock is very tight, and therefore oil and gas cannot come out on their own during production. And therefore, it would certainly require some special technology to first create permeability, which will be the pathway of the oil to move from the reservoir to the wellbore and then start producing. So this technology is called fracturing the rock, and since the water is used in this method, it is called a hydrofracturing. Some of the examples of unconventional reservoirs would be tight oil and gas accumulations in sandstones, shale gas accumulation in shale sections, and coal bed methane accumulation in coal. Hydrofracturing has a great impact on environment. So it has been touched upon here. Now, in the second section, we would be describing in very short the on-land surface production system, which is available for production and processing of the well stream. The first part is obviously the production well. This is the production well from which the well stream is coming from the reservoir. I am saying well stream and not saying oil coming out because The fluid, well fluid, is not a single phase oil. It is a three phase fluid which is having oil, gas, and water, and therefore it should be initially called as well stream or well fluid. So well fluid goes from the well through the pipeline, which is called as well flow line. It goes to Group Gathering Station GGS. GGS is like this. You can see some parts of it. It is a huge installation, it's a huge area in the oil field, and you can see many GGS in a big oil field. Now, it has many installations, many equipment within. These are oil gathering manifold, separators, emulsion treating facility, desalter, dehydrator, and crude stabilizer. Now we will see these one by one in very short, just to understand why I am taking this in the context of environmental issue. The oil, sorry, the well stream coming out from the well is coming through the well flow lines to the GGS. And the gathering manifold is a pipe. It is the receiving point of the well streams from all the wells around that GGS. Second is separators. The well stream from the manifold goes into separators. This is separator. What happens here? This equipment separates the well stream into oil emulsion, gas and water, three phases. Oil emulsion, it is still emulsion, not oil. Here, some water comes out as waste. You can see here, it is a schematic of a separator. The well stream enters from here with a force. Here is an inlet diverter. The direction of the fluid is changed suddenly, and the velocity is also reduced. So there is a flash and separation of phases based on gravity. The gas comes at the top, then oil emulsion, and then water. The water comes out from a nozzle, and it is a waste. So we generate waste at separators. This is demulsification unit, which is called as heater treater. What happens here? The oil emulsion, oil is in the form of emulsion. Water in oil emulsion. So it has to be broken. So in this equipment, it breaks the crude oil emulsion and separates the earlier emulsified oil and water. Now it is oil. So here again, some wastewater comes out from the equipment. This equipment is just like separator, only that there is a fire tube which provides heating to the oil emulsion. And we are aware that the heating, it breaks the emulsion. So heating is used to break the oil emulsion. Desalter, dehydrator, they remove the salts and water which are present in the crude oil now, and again some waste water is generated. Crude stabilizer. After the entire processing of the crude oil, they are stored at atmospheric pressure, and therefore it is important that the oil is stabilized means it will not have any vapor phase. And therefore, in the crude stabilizer, we do some exercise in which the C3 propane plus components are increased in the liquid part and the methane and ethane are removed from the oil part, liquid part. So the crude oil is stabilized, and now the entire processed crude oil goes to another installation called central tank farm. You can see here, this is a central tank farm. It is a huge area installation which is having huge steel tanks where the oil is stored before dispatched to refinery. So the oil is stored here at the atmospheric pressure. And because it is stabilized now, it will not have much vapor pressure, and in this way we will eliminate environmental and fire hazard. This was about crude oil. Now what happens to the gas which has been separated from the well stream? Gas, if it does not contain any acid gases like H2S, CO2, etc., it can be directly sent to sales. If it is having some acid gases, H2S, CO2, mercaptans, etc., they must be treated. So there are two major treatments for the natural gas. One is gas sweetening, in which H2S and CO2 are removed. This is a sweetening plant, and it is a schematic of the amine process of gas sweetening, which is the most common process. Amine is a base, so it reacts with the acidic gases H2S and CO2 and thus removes from the gas. Gas dehydration plant. Apart from the acid gases, the gas also contains water vapors. It has to be removed. So here the water is removed by mainly by glycol absorption. It is a schematic of a glycol absorption process. Now, in this case, some water is again generated. So you can see that every time during a treatment of either oil or water, sorry, I mean gas, some quantity of wastewater is generated. This was about the onshore or on land crude oil processing system, which is mainly group gathering station. Now we will see in very short what is happening in the offshore part. So we will see about offshore surface and offshore subsea production system. We will see what is offshore surface system. The upper photograph is of a very conventional, very familiar oil platform, as we can see in the offshore area. This is called an offshore oil producing platform. In this case, the water depth is shallow. The wells have been drilled on the seabed. The well stream from all the wells are coming through riser up to the platform. At this platform, the processing takes place, means the separators, demulsification unit, etc. Everything is placed on this platform, and therefore it is called as surface processing. Offshore, but surface processing. On the contrary, in the deep water areas, we don't have such kind of platforms. We have ships kind of thing or semi-submersible platforms. In this case, the entire processing system is installed at the seabed only around the wells. So you can imagine a GGS kind of a thing installed at the seabed. So all the manifolds and jumpers, separators, demulsification units, etc., etc., everything is placed at the seabed. And the well stream is processed right at the seabed. Oil and gas moves up and water is treated and pushed into the ocean again. It is called subsea processing system. This has many advantages over the surface processing. The most advantage is that it is saving great energy. Now we come to hydrofracturing for unconventional reservoir. I told that hydrofracturing is a process which creates a huge environmental impact. So we will see what are these and how they are creating environmental issues. Now, what is hydrofracturing? See this diagram. This is a schematic of a well bore. This is a well bore. This dotted area is the oil reservoir. This triangular things are the perforations which have been made in the reservoir rock. But since the reservoir is tight, means the permeability is very low, the oil will not flow on its own. And therefore, what we do, we inject a fluid, especially called here as hydrofracturing fluid or frac fluid, into the wellbore. It passes through the perforations and goes into the oil reservoir. And the pressure of the hydrofracturing fluid is much higher than the pressure, than the formation fracture pressure, means the fracture pressure of the reservoir, much higher than that. And this creates the fracture. It will fracture the formation here. In the second diagram, we can see this is the horizontal well. These are the fractures. We can see the fractures originate around the wellbore and travel or propagate inside, deep inside the reservoir. And ultimately, these fractures are propped open with the help of propends, which are basically sands, and these provide a high conductivity or high permeability pathway for oil to flow. Now, having this systems in the background, what we have, discussed so far, now we move on a detailed investigation on the environmental impact of on-land and offshore production system, including hydrofracturing. We will analyze the impact under four categories. One is impact on air, second, impact on soil and groundwater, third, impact on what was that? Forgetting. Impact on water, and then the generation of wastewater. Now, first we will see the impact on air. This slide you have already seen just now in the drilling part. The same pollutants are here also in the production area. But I will emphasize again on the CO2, methane, sulfur hexafluoride, and hydrofluorocarbons, which are the greenhouse gases and responsible for global warming and climate change. These are the major environmental issues which have very long term effect, global effect. Now we will see what are the sources of air pollution. The sources of air pollution could be many in a production operation. One, combustion of fuel, the simplest one, in the engines, turbines, boilers, compressors, which are normally used in the oil field for several jobs. Second is combustion of low pressure gas in flares. You can see here in this photograph, it is a GGS and it is a flaring tower. You can see the gas burning here. It is emitting CO2, methane, etc. in the air. The low pressure gases are not utilized generally. They are sent in the flare line and they are flared. Third is combustion of fuel in transportation. Several vehicles, transport vehicles, heavy vehicles, buses, trucks, etc., are moving all the time at the site. So the fuel which is being consumed there, the exhaust, that creates air pollution. We are also having process emissions in the gas dehydration and gas sweetening plants. At many points, many process emissions, for example, H2S, acid gases, carbon dioxide, hydrocarbon vapors, they are coming out at many places in this flow chart, in this process, flow process. Now, fifth is venting emission. Venting emission occurs when we are loading the vessels in the offshore and tankers in the onshore with crude oil for transportation, and also when we are putting the oil in the tank storage tanks. And we are also aware that, like human beings, the storage tanks, they also do breathe, which is called a tank breathing. During that also, some vents are here there, which goes in the atmosphere. Six is fugitive emissions. Fugitive emissions are mainly methane gas, which is emitting or leaking from the equipment, piping components, pumps, valves, etc. And these are the leakages because the nut bolts are not, I mean, tightly fitted, or there is some corrosion, some a breakup, I mean, the breakage is here there. So there is always a leakage of methane in the atmosphere. It is I mean, a fire hazard as well. Now we will see how to reduce this air pollution. First of all, we should reduce the fuel consumption in our machines which are working in the oil field, in the vehicles, in any machine practically. And this can be done if our machines are energy efficient. If they are old one, we must replace them with the new or the upgraded versions. We should also increase the use of the gas fuel over the liquid fuel in our engines because gas fuel is less polluting. Third is methane emission reduction. You have seen that methane is the most powerful greenhouse gas and therefore it is a main carbon emission agent which is responsible for global warming and climate change, and also it is a health and a big fire hazard. So what to do? For controlling the methane emission, we must first detect from where it is coming out. We should measure how much it is, and then we should do something so, so that it is eliminated. For this, we must expand our leak detection process. Every time we should be, vigilant and checking all the leaking points possible and check them and repair them. We can replace or upgrade the old equipments which are highly, leaking. We can replace and repair the pipelines, reduce the venting during storage by applying some technology and reducing the gas flare. Gas flare is the major agent of carbon emission and also a health hazard. This is happening because we are not using the low pressure gases occurring in the processing system. So we must recover the low pressure gases from the pipelines, from the tank, from the wellhead casing, and try to utilize that for various purposes in the installation itself, or we can send it in the gas sale pipeline. Fifth is reduce venting emission. We should recover the vent gas. There are technologies for this. You can see here the gas flare is a common feature in both on land and offshore production systems. Now we come to impact on land and ocean. Land and ocean pollution. It could be because of spillage and leakage of either oil or chemicals on land part or in the ocean water, which will contaminate the surface and groundwater in case of onshore areas and ocean water in offshore areas. It is a big fire hazard and also health hazard and a environmental hazard. You can see here, this is a offshore platform and in this huge area the oil spill has occurred. You can see this is all oil spill. You can see here oil spill on land which has destroyed the vegetation. It is oil spill in a river which has caught fire. So how to reduce all this? This can only be done by very strict environmental considerations applications. We should follow the environmental regulations. We should follow the very high safety standard to avoid accidents. And in case the oil spill has occurred, it is removed with the help of bioremediation processes, which is effective, but it takes long time to completely eliminate the spill. Now here again we will see some accidents. Accidents are not a routine environmental issue, but I am just showing you that in case accident happens, it will create a very huge environmental impact. Now you can see here in this upper diagram, it is a huge oil platform which caught fire and burning. It is a gas pipeline subsea on the seabed which had leakage. Gas came up and it caught fire in the ocean. And it is a recent accident on February 3 in Niger Delta when a FPSO caught fire. It is a around 48 years old FPSO which caught fire. So these are accidents, but it is not included in the routine environmental issues and impact of oil production. But we can know about all these things. Now we come to impact on water resources. Impact on water resources pertains only to hydrofracturing part, not on the conventional on land and offshore oil processing part. The water resources issue will be discussed in three parts. One is freshwater acquisition. Freshwater is the main component of the fracturing fluid, and as an estimate, around 3 to 5 million gallons of water per well is used in one hydrofracturing. So obviously, it is a big issue and it has great impact on limiting the quantity and the availability of fresh water for humans, for agriculture, for any other thing. We know that fracturing fluid is basically made of a base fluid, which is water. It is around 91%, in which some chemical additives around 5% and propane or sand around 9% are added. So when we are mixing the chemicals and propane, etc., in the water, what can happen? There could be spills either of the chemicals itself or hydraulic fracturing fluids. And we know there are more than 700 various chemicals, mostly hazardous, which are used in hydrofracturing. And therefore, these spills can very easily reach either to the surface from the land movement or to the groundwater by percolating in the subsurface, and it will contaminate the drinking water. Third is we are injecting the fracturing fluid into the well. We have seen that earlier. Now, during frac fluid injection, there can be some frac fluid leakage pathways which will contaminate the groundwater. One can be the surface spillage of frac fluid and the chemicals, which has been shown by 0. It will contaminate the groundwater. Then well casing leakage. We are aware that we are injecting the fluid at a very high pressure. If there is any leakage in the casing, the fluid will enter here and it will go up and contaminate the underground water. This is the fractures, and if the oil reservoir here is connected somehow with the groundwater bed through faults, the frac fluid can go to the groundwater and contaminate it. So these are some of the leakage pathways possible. Now we come to D, generation of wastewater, which is produced water. Now you see how it is generated. We have seen earlier that the wastewater is generated at the on-land GGS, at offshore processing platform, at subsea processing, and during flowback in hydrofracturing. This is a huge volume and it is highly contaminated, highly risky and hazardous, and we cannot throw it in the rivers or ponds anywhere. So, wastewater must be properly treated and then disposed of. Now we will see how the water is treated and how it is disposed. You can see this is the produced water. To understand the hazardous nature of the waste water, first we will see the produced water constituents. These are salinity, which comes from the formation itself. It is mainly sodium and chloride, and the salinity can be as high as 2 lakh milligram per liter. There can be suspended solids which are coming from the reservoir, mainly sand, silt, coal, etc. There can be oil, grease, hydrocarbons, and some organic matters which are coming from the reservoir, and some fracturing chemical additives. It also contains gases and volatile organic compounds, methane, CO2, BTEX, etc. Iron and manganese also come from the formation reservoir. So is the barium, strontium, boron, and bromide. Also, trace metals, for example, arsenic and chromium are there, and radionuclides are also there, which are highly hazardous. They are radioactive materials which are there in the formation and they flow in the formation water. Now, having seen the contaminants part in the produced water, now we will see what are the produced water treatment technologies available or which are in practice mostly. We'll deal with some major, important, most common practices. Number one is coarse strainer. These are just steel buckets kind of a thing with a screen which can remove mechanically the solid particles based on the size. So it will remove the suspended solids. Uh, I, it is to be emphasized that the waste water contains suspended and dissolved solids both. Now we are talking about the suspended solids which we can see. Now coarse strainers, they can remove solids bigger than 250 microns. I'm just very briefly describing them so as to show you the wide variety of technologies which are being used to clean the water before disposal and to ensure that our water has been cleaned and as per the environmental laws and regulations. Second is gravity settling tanks. These also remove the large particles by the gravity method, gravity principle. Water resides for a very short time in the settling tanks, and it enters in the tank with a high flow rate. The suspended particles bigger than 50 micron can be removed. Here you can see a schematic of a horizontal and a vertical gravity settling tank. It is just like separator. The water will come here with the speed. Diverter is here. The direction will change. By the gravity, the solids will settle at the bottom and will be taken out, and the clean water goes up and it will come out from here. Third is water clarification. These are basically the chemicals called as flocculants which are added to the wastewater in order to first coagulate and then flocculate the finer particles into larger ones. And these can now be easily removed. Coagulants are mainly inorganic compounds of aluminum, iron, and copper. Mostly oil is removed by this method and also fine solids. Fourth is hydrochlum. You can see here in this diagram, the water enters through the volute inlet. Change in the flow direction forces the water to spin in a radial vortex pattern. You can see here this centrifugal force acts on the solid particles and it forces the particles towards the internal wall of the hydrochlum, and ultimately they get settled at the base and come out as the outflow here. And the water, because of cone convergence, move upward and comes out from the vortex finder and comes out from the, here it is the treated water. 50 to 100 micron size particles can be removed by this method. Fifth is settling points. Settling point use gravity principle to separate the suspended solids. It also removes iron and manganese because of the oxidation that occurs in the pond due to dissolved oxygen, and also some organic chemicals, they get degraded due to photolysis. So it is a settling pond, water coming from, I mean here, the particles are settled as per the gravity and water comes out from here. Plate settler. This employs the principle of gravity plus coagulation and flocculation combined effect. Mainly suspended solids, iron, manganese, zinc, some organic matter, and radionuclides are separated by this equipment. The water enters from below. These are the inclined plates. Water moves up because of the effect of coagulation, flocculation, and gravity. The sediments, they settle at the bottom and come out from here, and the treated water moves up and come out from the upper side. Dissolved air flotation. This is a method which separates suspended particles and some other organic materials also, which are lighter than water. In principle, it uses the gas bubbles which take up or lift the lighter particles to the surface of the water tank. and they are removed. The main contaminants which is removed here is mainly oil and grease part of the produced water. Also, some lightweight solid particles, some organic matter, gases, and some volatile compound also get removed. You can see here produced water enters from here, air enters from here, bubbles are created, there are inclined plates, water will move up, the bubbles will capture the oil and grease and make foam kind of a thing, froth, and it will come up and can be removed from here, and the water will come out from this side. Next is electrocoagulation. This is basically an electrolysis process. You can see here we have an anode, cathode, and the electric circuit is completed. Here we have kept the water which acts as electrolytic agent. Now the cell is complete. Now what happens? The anode, which is the sacrificial electrode, is made up of iron or aluminium. It produces metal ions. These metal ions neutralize the suspended charged particles and they form metal hydroxide precipitates that will have two fate. Number one, either these hydroxide precipitates, they will move up as flocks, froth or foam, or they will move down and settle at the bottom of the tank as sludge, depending on the density. The main contaminant which are removed in this method is emulsions, because oil emulsions are difficult to be removed by any other process. Also, suspended solids, some heavy metals, organic matter, biological contaminants, and fracturing chemicals can also be removed, but the main target is oil emulsions. Then we come to filtration. It is simply filtration. There are two kinds of filters mainly used. One is granular media filters. It is also called as sand filters. You can see here it is a steel vessel, cylindrical vessel, in which there is a filling of bed of graded sand or gravel or anthracite or graphite. The water enters from here, it will pass through this bed and the cleaned water will come out at the bottom and the particles will be absorbed at the sand bed. So in this way it is filtered. 25 micron particles can be removed by this method. Second filtration method is cartridge filter. It is basically a cylindrical vessel in which the cylindrical filters are encased along the side of the vessel, and in the center we are having a perforated pipe. The waste water will enter from here and it will move from the outside of the encased cylindrical filters, and then it will percolate the filters. The particles will get absorbed at the filter material and the clean water will enter in the center of the vessel, and that is open to a bottom pipe, and the clean water will come out from here. Less than 25 micron particles, suspended particles, can be removed by cartridge filters. Next is microfiltration or ultrafiltration method. In this case, there are various membranes are there. We can select membranes as per our requirement, and pressure or section method is used to filter water through these porous membranes. Main target is trace particulates and oil and grease. Then nanofiltration. Till now, we have talked about removal of suspended particles. Now, we will talk about removal of dissolved solids in the wastewater. So, first method is nanofiltration. It removes the divalent ions like calcium sulfate and calcium carbonate mainly. However, it can also remove some ions like sodium nitrate and chloride as well. This is a photograph of a nanofiltration unit. It is really a very huge plant, and these cylindrical are uh, filters. These are the nano filters stacked in a case. The principle is very simple. There is a membrane, and under high pressure, the water is pushed through this membrane, and it allows only the water to move through. And the ions are retained here only. And in this way, we clean the water. Next is membrane distillation. It is basically a heat driven membrane separation process. What is done here? We introduce the produced water in the here. This chamber is heated, so our water gets heated and it gives vapors. This is membrane. This membrane allows only the water vapors to pass through. These come here, they are cooled, and then water can go out. It is now treated water, and the ions are retained in this section. Dissolved salts can be removed by this method. Next is well-known ion exchange method of water softening, means removal of Ca and magnesium ions. Demineralization is removal of other minerals, and ion exchanger mainly consists of sodium zeolite cation exchange resins. And by this way, we can separate many dissolved ions like calcium, magnesium, fluoride, nitrate, arsenate, selenate, chromate, and anionic uranium complexes. Bioreactors. It is a vessel in which the water is pushed, air is pushed to create air bubbles, and this air sustains the biological activity inside the vessel. The bacteria, they degrade organic matter, and by this way, we mainly remove oil, grease, and hydrocarbons, and some other things as well. Last is desalination. It means removal of NaCl, dissolved sodium chloride. Produced water is forced under pressure, you can see, to flow through a reverse osmosis membrane, which allows only water to pass through, and in this way, NaCl particles are retained in this section. It can remove NaCl. So it is known as desalination. So we have seen around 15 most used and effective produced water treatment technologies. Now, the water has been treated, now it will be disposed of. There can be above ground disposal, either by releasing the treated water into a river or lake or pond, or by putting it in an open pond for evaporation. Second, underground disposal. The water after treatment is injected either in dedicated disposal wells or in the water injection wells for enhanced oil recovery. It can be reused in various oil field jobs and also reused in hydrofracturing operations for making frac fluids. Now we come to way forward. If we see the global oil reserves, they are continuously increasing. 2000, 2010, and 2020. It means more oil exploration and production will happen in times to come in all the regions of the world. Either it is Middle East or America or CIS countries or Africa or Asia Pacific or Europe, everywhere. Similarly, gas reserves are also increasing. So more gas production. Gas is a clean fuel and it is in greater demand. Shale gas and CBM will also increase and therefore fracturing will continue. Shale gas reserves, you can see China, it is in trillion cubic feet. China, US, Mexico, Argentina, Australia, South Africa. So more shale gas exploration, more hydrofracturing. Similarly, CBM, it is a clean energy and huge reserves are there. Russia, China, Alaska, Canada, US. So more CBM production means more hydrofracturing. So production of oil and gas will continue. Fracturing will continue to be the prominent method for production of shale gas and CBM. Associated environmental issues will be continue to be challenging and there will be strict regulations to control all these. So what should be the industry imperatives? Like previous also, first and foremost is to reduce carbon footprint, reduce air pollution, minimize oil, chemicals, wastewater spillage, adopt nature-friendly practices, develop environment-friendly, high-performance and cost-effective oil treating chemicals for processing of crude oil. Also effective produced water treatment and disposal methods and technology. We should look for environment friendly, high performance and cost effective fracturing fluid additives. Now, we must adopt the emerging water free fracturing technology like liquid propane, CO2, N2, and helium, which are used as fracturing fluid instead of water. Also, air fracturing, explosive fracturing, exothermic reaction fracturing, and plasma pulse fracturing are also under, R&D development stage. These water-free fracturing technology are still emerging. So there is a need for faster research and R&D efforts so that they can come up as a cost-effective commercial alternative for hydraulic fracturing, and we can save the nature, and reduce the global warming and climate change. Thank you very much. This completes my talk of today.
Thank you, sir, for your enlightening presentation. It was
Thank you.
a very practical and engaging session. Participants are requested to interact with the resource person if they have any query. Thank you, sir, for speaking about liquid and solid waste generation and how to handle span drilling fluid, wastewater, well site drainage, and telling about the environmental impact of online and offshore production system, and particularly the release of methane gases from different installations, and because it is one of the significant contributor of global warming, and how to reduce air pollution by containing methane emission, and sharing your knowledge about land pollution due to oil spill and in onshore and offshore, and about freshwater acquisition processes, and for which government clearance is required, and safe operations that consume so much of fresh water, and lastly about how to move forward with the coexistence of different issues that are involved, and how to take up those sustainable approaches uh, in future. We really enjoyed your presentation regarding environmental impact of oil well drilling operation and disposal of waste, and environmental impact of oil production operation and disposal of waste. We appreciate your making time in your busy schedule to speak to the attendance of this faculty development program. Thank you again for your time and for your enlightening speech, sir. Thank you, sir.
Thank you very much, Dr. Neo. Thank you very much. Thank you,
Welcome.
participants.
Thank you, sir. Dear participants, we'll meet again at 12:30 p.m. for our next session.